Hello everyone, I'm Mandeep Singh 𝐒𝐲𝐬 and today I'm back with another system design mock interview where we will be having a discussion on a problem statement. I have someone with me who has a great experience in designing systems. So we will start with a basic problem statement and then let him drive how like where our interview lands or where our software architecture lands. So the problem here is that what we basically have to do is you might have seen Instagram stories or WhatsApp status or Snapchat. I'm not sure what they call probably stories there as well. But the idea is that you have to design that kind of feature in your social media application. And yeah, let's get started. That's the idea of the problem statement.
Yeah, so here, so I'm actually putting the problem as design uh, stories feature. I would like to discuss some functional requirements with you.
Okay.
So I will add some. Let me know if you want to add something or you have some views over it.
Yeah,
So I
sure.
think user should be able to create new stories. So now by stories means that a user can capture a photo, a user can capture a video, or user can upload that via gallery as well. So that is the first function requirement that I can think about. Second is we can also have a support for text only stories as well. So some user actually put the status or the stories with text only, right?
Okay.
So that is also one thing that we can see in the stories feature, whether it is Instagram or whether it is WhatsApp. And we shall have support for stickers, GIFs, emojis. So that is also something that we can see. So that will be my third one. And we can also, user should be able to add the music. So music should be also be able to add, user should be able to add the music from the library as well. And we can see that in the stories, we have a tagging feature as well.
Hmm.
So tagging or the mentions should also be there. That is also one thing I feel. And there can be like addition of hashtags and locations, so we can see in the story that this is also a feature there. And we will also keep this expiration thing into place, that stories get expired after like some like some time period, maybe 24 hours or something, so ephemeral basically.
Hmm.
So so let's keep it like in 24 hours story gets expired or something. So
Okay.
that is the ephemerality I will like to keep here. And user get notified also, gets notification when someone replies to the story,
Okay.
right? And so as of now, I would like to keep these. We can also add those things like like adding or removing people for viewing the story, basically hiding the feature. So maybe in the scope,
Yeah, I
maybe out
think
of the
like
scope, we can
for
have certain
the
requirements in the
scope
scope out of
of
this, and somewhat
yeah, for the
yeah,
scope of this
please.
discussion, we can like keep these kind of features as a additional kind of thing because anyway
Yeah,
we have
yeah.
limited
So
time for the discussion.
yes. So I think until the first to six or first to seven should be the in scope requirements we can keep. Others we can keep as out of scope as of now, and we can see if we have time for the further discussion.
Yeah, sure.
And the NFRs that I can see for is the minimal latency. So when we create the stories, we publish, and when we view also. So I think minimal latency for creation of the stories, and like viewing the stories as well. So latency in the context of creation, publication, and viewing. So that should be the first NFR. So simultaneous users can also be there at a peak usage time. So our system should be able to support that as well. And system should be highly available as well. So system highly available should be there, because we can see that systems like Instagram or WhatsApp, so they majorly support availability. So highly available system is the second NFR that I can think of. Another thing that I can think of is highly scalable. System should be highly scalable. So that is also one thing, because there will be the growth in the number of users and the volumes of the stories that will be created. So
Mhm.
in that point, I think that it should be there. So anything that you would like to add here, or you want to question on anything here, Mandeep?
On the minimal latency part, right, we should define some kind of numbers that for
I
let's say
think 500 less than 500 milliseconds of latency I would like to keep here.
for creation
Uh,
or like viewing.
for
I mean, viewing,
like
viewing it could be that we take more time, but no, not
yeah,
viewing, the publication part. So publication could be that it takes time to upload some kind of media and all, but
yeah, yeah,
viewing
yeah,
should be faster as
yeah, yeah.
compared to creation, basically.
Yes, yes. So I think for the viewers, everything is real time if it is done under 200 milliseconds of latency.
Hmm.
So we can keep the ballpark number of our whole system, I think, around 300 to 400 milliseconds of the latency numbers. That is what I feel here.
Okay.
So yeah, like
Yeah, if you want, like we can keep for creation at a higher end because like you
mhm.
also might have seen like whenever we upload our stories as well on Instagram, like if you are uploading media, it takes around 1 to 2 seconds. For viewing, definitely
Yes, yes,
it
yes.
takes less time.
Right, 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 right. So yeah, like I think yes. So I think yes, viewing should take less time. I think around 300 milliseconds of
Yeah, sure.
latency for the viewing.
Yeah, we can keep
I
that.
don't know if we should keep anything for creation or publication per se as a strict latency constraint. So do you want to add up over that?
Yeah, I mean that's fine. Till that it is not taking forever to upload the stories.
Yeah.
If it is done in like a time where a user is not much impacted, then we are good. We don't have to consider that number. Let's assume it that it's
Yes.
below 5 seconds for the creation and for viewing it is below 500 milliseconds.
Yes. So I think that should be enough for that. So anything you want to add up more on this? Uh, we can go with the
Uh,
capacity estimations. Or
yeah, I mean it's sounds good that system should be available and scalable because
yeah.
we are talking about like the scale can increase definitely over time.
Yes, yes,
So
yes.
yeah, yeah,
So
we can move
we will
forward.
do the estimates and we can have a ballpark number for the scale as well,
Yeah, sure.
which we can have.
Yeah, sure.
So let's do some ballpark capacity estimations. So I'm taking into account that something like Instagram has around 500 million of daily active users. So that is what I'm taking as of now. And percentage of users that are posting the stories, let's take it uh, something around, like 10%. 10% of daily active users post the stories. So if I take 10%, that is around 50 million stories are created per day, right?
Okay.
Created per day. So if one user posts one story per day on average, and there are around 10% of the daily active users doing it, so that will be the number. And let's take the average story size. So what can be the story size here is, like, let's say like we are taking photos, videos into account and all. So let's say that it is approximately 2 to 3 MB of stories. Story size will be there, average story size. So per user, let's say that each user averagely is viewing 5 stories. So that is also I'm taking into account average stories viewed per user. So every user per day is viewing around, like 5 stories. That is something that I will take as of now. So if I talk about total story views only, so it will be around 500 million users we have. Each user is on the average viewing 5 stories. So that will be around 2.5 billion views per day, right? So that will be the number. And if I talk about the queries per second that our system needs to handle is like 2.5 billion. Around like, so in a day, we can have like 10 raised to power 5 kind of seconds. So approximately, right? So it will be like around this number comes around 25K. So that will be the QPS for our system that our system needs to handle on the ballpark numbers that we have given. So if I talk about the storage, so like we have 50 million stories that are created every day, and each story is around 2 MB on the average size if we take. So it will be around like 100 million MB. So that is roughly around like 100 TB per day. So it will be around 100 TB per day of storage that is required for us. So that's why I think our NFR also suggests that our system needs to be highly scalable, because we have this 25K QPS queries per second and we have 100 TB per day as a storage requirement for us. So any questions on this, Mandeep? Anything?
Oh yeah, I mean it's on estimation size, it's okay. Like we
Mhm.
can discuss during the architecture. Like
Yeah.
if we
Let's
have
have a
like
let's
we
go into
have
the basic API flows, like API designs and everything. I
yeah.
would like to discuss that also here. So let's say on the API side, if I say so, first API that comes into our mind is a post API. So a user want to post the story, right? So we will have API stories, and like what will be the like payload here is that in the request payload will be that there will be a so request here will, I think it should look somewhere somewhat like so in user ID will be there, media URL will be there. Of course, like if we talk about the media, right? So we will like to cache that media somewhere, maybe CDN or something, right? So that media URL will be that where that static media content is present. So media type can be there, and like what other things we can have, location, because we want it that our stories we should be able to like post the location as well. We should be able to like have the hashtags into the place as well, so hashtags will be there.
You
And
can keep some sort of metadata which can include all these things, which can be
yeah, yeah.
expected in future. So just include metadata.
Mhm.
Uh,
We can have a meta. Yeah, we can say that metadata will be there in the request. Like
yeah,
with the major media, we will have the metadata. So user ID, media URL, media type is one thing, and metadata will be like like what is the location, if stickers, if any, emojis, if any. So creation time will be there, right?
yep.
So yeah, creation time will be there, and if we wanted, we can have include exclude users, but that is out of scope for this. So yeah, like this will be our post API request payload. Right. Other thing that I feel is, should we be able to modify the stories as well? I'm thinking that if we can, I don't think that we can modify the like
We
stories, right?
can skip that requirement. Yeah,
Yeah,
even
yeah.
if it's
So we can,
supported on these platforms, we can skip it.
yeah, we can have a delete API. So delete API will be very simple. So we will have a delete API for the stories, and we will have a story ID which we actually want to delete. So that will be the simple endpoint we will have. Another we will be having getting the feed. So that is something that is important for us. So we need to generate the feed for the user as well for the stories. And can there will be any so are we taking into account the reactions of the users? We are not taking into account as of now, right? Like a user likes or reacts, or are we? Yeah.
We
Like
can skip that for now.
okay. So sharing also there can be something if we want, right? Or I think we can come back to this API endpoints later on, right?
Yep, yep.
So let's keep it as it is as of now. Let's try to understand the like storage here and the database schema that will look like.
Before
So,
that, I wanted to understand more on this API of the stories, right? Where you have user
uh
ID, media URL, and media type.
yes,
So
yes.
I wanted to understand how you are generating this media URL basically.
Media URL, I feel that it should be, so it is a static content, so I think it should be, like cached at some CDN layer. But if I go with something of a basic architecture, so it should actually be like we should use a blob storage, and uh, all that
No,
static
that's
content
fine.
should be
I mean,
stored in a blob
we don't
storage, and
have
it should,
to go to
hello,
storage part right now. I
yeah, yeah.
so if like how I think is probably your direction could be in that way also.
Hmm.
So the idea generally is that I think you're trying to media earlier and you get some URL from it, from your
Yeah,
servers, and then you
yes,
use that URL to pass in this request. So is that the
yes,
idea?
yes.
Okay.
Yes. So basically, we have this static. So majorly, it will be a static content, right? So
Yeah,
better
yeah, yeah.
to, I think, store it in some CDN layer or some cache layer, and get the URL for that, and we can use that URL. So that is the idea that I'm thinking as of now. If there is something in your mind, we can discuss through that also.
Yeah, for now it's fine. I just wanted to get clarity to me as well as like the viewers of this video that you are first uploading the media and then you are getting some URL and then you are using that URL to basically upload the stories.
Yes,
Okay.
yes,
Yeah,
yes,
we
yes,
can we
yes.
can move forward.
Yes. So on the database part, what I feel is that like I would like to discuss like what how we can, like what database we can use, and for different purposes, and what will be the database schema look like. So I think for user tables, so user table will be a very simple table, right? Which will have a user ID, a username will be there, maybe a email, maybe a full name,
Yeah, we
right?
can
Profile pic.
focus on the
So
main entities of this
so
discussion. We
if
don't
we
want
talk
to.
about the stories table, right?
Yeah.
So stories table will be having like, like when we create the stories table, so it will be having like story ID and user ID who is actually posting that, right? And a media URL will also be there. So as of all that metadata basically will be there inside that stories table there. So that is what I feel it should contain actually. So majorly a story ID. If we are using a relational database, then it should be a primary key for that. User ID will be there, media URL will be there, and we will have all that media type created at, expires at, and all that stuff. All that metadata will be there in
Probably
that
like
stories table.
just one thing, like probably we should discuss the architecture first and then we can go into like the database. I think that will give more clarity.
Yeah, sure, sure.
So let's
So
discuss the architecture and then like whenever we are actually saving the data, we can think on like how we want to store it.
sure, sure, sure. So here we'll be having, let's say a client will be there, and we will have a API gateway. So API gateway is basically for rate limiting and authentication and routing as well. So I will have a API gateway into the place. And first thing is that we will have a like user service as well, so that the user is registered or not or something. If we want, we can take that, or we can ignore that. I think we should ignore that as of now. Let's have this that the users are already registered, right?
Hmm.
So if we have like, let's say that we have a story service. So I will have a story service in the place. So what story service should do is that it should handle the creation of the story, and it should handle like deletion of the story. So if we have those out of scope requirements also, like editing or archiving of the stories, we can do that too. But let's keep it to handling and the deletion as of now. So our
Yeah.
story service will do that. So let's say that like a request to create a story comes, so that will be actually routed to story services. And what will happen in this case is that like every like every static data or every like image, video, these kind of stuff, I would like to store in a blob storage actually,
Hmm.
right? Because what will happen is if we will uh, upload. So let's say that we have a blob storage here. So I will use something like S3 blob or uh, other like providers as well. So I'll use some blob storage. So in this blob storage we will have the media. So how it will work is that initially a request. So this blob storage will actually generate a pre-signed URL. So let's say that a user wants to upload a image or a video, right? So one of the ways we can do it is that we should like hit the API gateway should upload that content to story service, then story service should upload the content to the blob storage. So I think that will be a double hop and it will actually be two times uploading. So what we should do is that we should actually ask the blob storage to for a pre-signed URL, right? So this is what I will try to do, that we will get the pre-signed URL from the blob storage, and we can directly upload the like these images and videos to the blob storage. So the first call, so here our APIs will also be somewhat modified. So first thing that I would like to have is that you know uh, wait a second. So post API stories, pre-signed URL or something. Let's name it somewhat like this, so that it will fetch the pre-signed URL. And also, what we will do is that we will have that story metadata that we will send in the request. So in the request, we will send stories metadata. So parallelly, what I feel is what will happen here is that we will have a story DB, let's say,
Okay.
and in the story DB we will have the so there will be the first post request that we will request the blob storage pre-signed URL from the blob storage. So in the meantime, in the story DB the metadata and all that stuff should be given to this. It should be uploaded to this, and we will request the pre-signed URL, and the blob storage should return the pre-signed URL to us, and the story creation should be in progress. So there will be a field in our story table that will say that okay, like story creation is in progress as of now. So this is what I feel should be the first call of our
So you
system.
are generating some kind of story ID in the first call itself, and then you are using that
Yes, yes,
story
yes,
ID
yes,
in
yes,
the.
yes,
Okay.
yes. So that is what I feel it should be more efficient, because I would not like to do the double upload kind of a stuff. So I will directly have a pre-signed URL from the blob storage, and in the meantime the story DB we will have an entry which will have a field like story uploaded or not, so like in progress or uploaded, like upload complete or something into the place. So we will fetch the pre-signed URL. So this will be the call here, like API stories pre-signed URL, right?
Yeah, got it. So basically, what you are doing as part of first API call is you are making an API call, you are retrieving the pre-signed URL and also a story
Yeah,
ID.
yeah,
That
yeah.
data
Now
is already stored
next
in
thing
your
will be
story
that with
DB.
this pre-signed URL, I will directly upload the the media on the blob storage, right? And we will also have this. We already got the media URL and everything, and we will store that in our story DB as well.
So
So
this is done in the
that is
first
what I
call
feel.
itself, right? And other information which are related to story that you are storing as part of the second call when you are posting that story.
Yeah, yeah, yeah.
Okay.
Basically, the media part, you
Okay.
can say. Media part, you can say.
Hmm.
I'm doing in the blob storage. So that will be the second call. Like we will make a second call to this pre-signed URL only to update the media, and we will mark the upload of the story as completed. Creation
Okay.
upload of the story as completed in our story DB.
Okay, you are
So
also keeping some kind of status in the DB that initially
yes,
it is
yes,
some kind of in progress,
yes,
and
yes,
finally once it's completely what you say like done, then you mark it as
yes,
complete.
yes,
Okay.
yes. So basically, story will look like something. It will have a story ID. It will have a media URL. So that will be our blob storage URL in this case as of now, let's say, right? It will also have a status. So status can be, let's say, in progress or completed, right? And user ID that has actually creating that story will also be there, right? So all that stuff and
Yeah,
creation time.
yeah, yeah, yeah.
So that will be there. So I think this suffices our story table very well. So yeah, so that will be the case here.
Okay.
So any questions you have on this?
So we are done with the story part, right? Let's
Mhm.
discuss on the delivery mechanism, and then probably like I have some questions right now, but let's have the discussion after we understand the delivery flow as well. So right now we have uploaded the story. Let's talk
Mhm.
about how you are delivering this story to the users who are following this user.
Right, right. So for that, I think we should separate that out to a different service. I feel
Why?
that can be a like because that is a read part for us. I would like to keep that separate. I don't want to keep the write path and the read part in the same service. So I want a separation of concerns there because if you see our system is mostly our system will be mostly read heavy, right?
Yeah, it is.
So that is what I will like to have.
Uh,
So yeah, yes,
let's say we have a different component. Let's
yes,
talk
yes.
about that, how you are delivering this story to the users.
Right, right. So I think there can be if we try to keep as it is. So I think we need to keep that follower table into account as well. Our let's say we have a feed service. Feed service will fetch the followers from the follow DB of that particular user,
Okay.
and we will generate the feed for that. So I know that it will not scale, but let's say that we are doing it as a sake of sorting out the function requirements first,
Yeah,
right?
let's start
Uh,
it and then we can think of if it present any bottlenecks at scale. So let's
right, right,
discuss the
right,
basic
right.
architecture.
That's what.
Yeah,
So
sure.
I would like to have a first thing I would like to have is that satisfy all the function requirements that we can have into the
Okay,
picture.
sure.
So what I feel is that we will have a separate feed service into the account. And what feed service will actually do is that feed service. So we will also have a follow table here. Let's say so how will the follow table actually look like here is that let's say we have user following and user followed. So I will think that it should be the partition key for us. And let's say that we have this as a sort key. So what will happen is that for a particular user, we want to generate a feed, right?
Okay.
So by this, what we can do is that our feed service will make a call. So and it can fetch all the users that particular user is actually following, right? So our feed service will get all the people that a particular user is following, and now it's time to get the stories as well, right? So if we talk about the stories here, so now I think that instead of a SQL kind of a database, I will go with a DynamoDB kind of a database, a NoSQL kind of a database here. Because what I will do is that I will generate a story GSI here. So I will generate a global secondary index for a story here as well. And what we can do by this is that let's say we have a user ID here that actually created the story. So that is the primary key, and we can have that we can have all the stories that are created by a particular user. So here we were having story ID as a partition, not primary, a partition key, right? And here I will have a user ID as a partition key in my global secondary index. So what it will do is that for a particular, so what here how it will fan out is that for generating the feed, there will be a call to the feed service. Feed service will make a call to the follow table. It will fetch all the users that are being followed by that particular user. And for each user, it will try to fetch the stories that were actually posted by that user, because there can be multiple stories as well, right? So it will actually fetch that stories by the users on the basis of increasing creation time. So we will have that as a sort key, the creation time as a sort key. So this is what I am thinking about, how it should actually work on the naive basis. So creation time as a sort key.
The idea here,
So
uh,
yeah,
I am also thinking, it just came to my mind. Like instead of creating a separate GSI, will it make sense to have user ID as a partition key in your main table instead of story ID?
in the story table you are saying, right?
Yep. So that way you
Uh,
can directly pull, because anyway,
because what will happen in this case is that initially we are uploading the metadata, right? And now what will happen is that we are also getting the pre-signed URL.
mhm,
And then again for that particular story, we need like we got the pre-signed URL, we'll be uploading the media, and like there will be a second call for like marking the status of that particular story as completed and all, right?
yeah.
So that is what I feel that we need a story ID
Yeah, you can have it
for
as sort key. I mean, if you need, that's fine.
uh,
User ID anyway
need
you will always have. Uh,
yeah, need to think about that, because the thing is there can be multiple stories by a particular user as well that we can have, right?
yeah,
So
yeah.
I think, yeah. So if we get a story ID as a sort key, let's say, so in that case, with the user ID, we can follow all the, like we can get all the story IDs. Yeah, makes sense. That also makes sense, I guess. Uh,
Yeah,
that also makes
just
sense.
the idea that came to my mind because again, creating a GSI is adding to the cost to our Dynamo. But yeah,
Yeah,
we
yeah.
can move ahead. It was just the
Yes,
idea
yes.
that came to my mind.
So this is the basic flow. So what it will do is that a single call to the feed service will fetch all the users followed by a particular user, and for all the users, it will actually fetch all the like stories by that particular user, and it will actually like generate the feed for that. So it will actually make the call to this. It will actually make the call to this as well. So so it you can see that a single like here it is a cache that like a single call is actually fanning out into the multiple calls, right?
Hmm.
So I know that this will not scale, but as of now, I feel that for the functional requirements, this is how we should work upon. We can go with how it can scale moving forward.
Yeah.
So, any questions as of now, Mandeep, you have on this?
I think you already mentioned around that this will not scale. We can definitely
Mhm.
discuss on like what are the bottlenecks that you see it
Mhm.
presents, and then we can take a discussion from there.
Yeah. So, first of the bottleneck, like I said, right? Let's say for a particular client, we need to generate a feed. So, for generating the feed, we will make a call, right? So, we will if a single, sorry, sometimes this
Yeah, it's fine.
escalate.
You can skip this arrow and create a new one. We don't have to perfect in the diagrams.
Yeah, actually, the cursor is not leaving that.
Press
Yeah,
skip.
yeah,
Okay.
yeah. I done that. I
Okay.
done that. Yeah. So, uh, yeah. So basically, let's say that a single call for a particular user to fetch the feed, right? Because if you remember, we have this get API stories feed. Maybe
Yep.
for a particular user ID, we want to fetch it, right?
Okay.
So the thing is that a single call to the feed service will fan out to multiple calls. So first it will try to fetch all the users that are followed by that particular user, and now it will try to have all the stories that are created by that user, and it will actually then it will generate the feed for that.
Yep.
So let's say that a user is following a large number of people,
Hmm.
right? So what will happen is like let's say a user is following like some number we can take like 10K people a user is following. So it will make a call to all the 10K, and it will try to fetch all the posts from all those 10K users, right?
Hmm.
So if you see that we have a typical fan out problem here
Hmm.
that we are able to see.
Hmm.
So that is the bottleneck that I feel is here.
Okay.
So this is a typical problem of like a fan out. So what we can do is that maybe we can have something a pre-computed uh, feed table. That is something that I'm thinking about, because that is a common read pattern we have for these kind of problems. So what happens is that, let's say user posts some story. So for all the followers of that particular user, we will have a pre-computed feed, and that will be automatically added to each and every feed of that follower. So
Okay.
that is what I feel.
So you
So
are
for
creating
that
some sort of cache at the time of story creation, and you can use directly at the time of feeding those stories to the users. Yeah.
Uh, before cache, I think we can have this. So basically, if you see that a user is trying to read the stories, and then we have fan out on read happening, right? So what I feel actually is that we can have a pre-computed feed kind of stuff as well. That
Yeah,
is
yeah,
what I
that's
feel.
what.
So
I mean, from cache, I meant that you are creating that cache at the time of story creation. So you are
no, no, yeah,
pre-creating that cache.
kind of. Basically, what happens is that let's say we have a follow GSI into account. So what happens here is, so let me explain the flow, right?
Yeah, sure.
So let's say we have a user followed, so that is a primary key. Oh, sorry, partition key for us. I have a habit of saying primary key. Primary key. So the thing we have is, let's say a user following, that will be a sort key. So with the help of this GSI, what happens is, let's say a user is posting a story, right? So we will fetch all the followers of that particular user, right? And we will have a separate pre-computed feed table for the followers, and we will just add the story that has been created to each and every feed.
Okay.
So that is what I'm saying, like a cache or something. So we will have a separate pre-computed feed. We will have, and in that, what I will do is, for that particular user ID, basically this user ID is user following. So a user who is following that particular user, right?
Hmm.
So what we will do is that we will simply add the story that is created by the user into the feed of that particular user,
Okay.
and it will just fetch the pre-computed feed from that. So it also has one bottleneck that can happen, but let's say this solution will work well. Let's say if a user doesn't have a large number of followers, but another user is following a large number of people.
Hmm.
So it will actually work well in that case. So basically a user creates the post, so we fetch all the followers of that user, right? And
Yeah.
we just go and add the story ID into kind of pre-computed feed of all the followers of that particular user.
Yeah.
So that is something that I'm thinking about for handling this fan out on read problem.
Hmm.
So first bottleneck that I can see is this fan out on read. So anything you want to ask here as of now?
Yeah, I mean, you keep on answering my questions, so I will again hold off my questions. And the one bottleneck which you mentioned, right? I think it pretty much solves the case for most of the users. But
Mhm.
a user with a huge following, I think we will have to discuss that on how we are handling
Right,
that.
right, 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 right. So let's say if a user has a large number of followers,
Yeah.
right, then we will have a similar fan out problem that will happen in this case. So what happens is that I let's say some celebrity just posted a post. So what our feed service will do is, it will try to fetch all the users following that particular user. Let's say they are million in number. So now what will happen is that it will try to do the million writes in the pre-computed feed.
Hmm.
Right. So this is also a fan out on right problem which we can think of that has happened here.
Yeah.
Right. So for that part, what I can think is that we should go off something with the asynchronous kind of a solution for generating the pre-computed feed for some set of users. So let's say that we have we have a queue where, let's say, this user who has a lots of follower actually so created a story. So we will have a story queue. So that story will be added in this story queue,
Okay.
and we will have feed workers or the asynchronous workers. Many asynchronous workers or feed workers will be there, right? Which will actually fetch and which will actually try to compute the feed. So that is something that I feel should be done. Or what other thing that I can also think is that apart from this, we can also have something called of a hybrid kind of architecture. So in that
Before that,
hybrid kind of,
can you quickly
yeah,
explain? I didn't understand the story queue, like how it's working. So you got some story request, you pushed that to the
yeah,
queue. It was pulled by the this
feed workers.
feed workers. Then
So
what they are doing?
yeah, so basically, here I'm taking into account of some queue, like I'm taking some queue that has at least once delivery of messages mechanism, right?
Okay.
And is highly scalable. So we can go with something kind Amazon SQS, right? So let's say when a new post is created, we will create the entry in that SQS queue, and it will have the post ID and all, and the creator user ID, etc. Right. So now what will happen is each worker here, right? So each worker will actually go and have a look at the followers for that particular creator, because in the
So
story
you
queue, right?
are you dividing the follower count somehow between the workers or like
I think we should do that. That it should actually look up all the followers for that creator, and kind of have that division into the place, so that those asynchronous workers can actually go and generate the pre-computed feed for all the followers of that.
okay.
So because challenge here will be the throughput for sure, because the throughput of that feed workers need to be very high, right?
Okay. So just
So
to like close on this like what you are thinking is that you have, let's say, 10 million followers for that user. So
yeah,
these activity workers will break into, let's say, 1 million each, and
yes,
then they
yes,
will try to write. This is how you are.
yeah,
Okay.
yeah,
Okay.
exactly.
Oh, so yeah, this is one of the approach. Yeah. You can continue.
Yeah. So another thing that I think of is flagging off actually. Let's say that we don't need to do a pre-compute for, like, let's say each and every post, right? Because let's say that a user is there, and let's say for celebrity, right?
Hmm.
So what we can do is, for a celebrity who actually, so celebrity, first of all, let's say celebrity posted. So what we can do is that we can flag that celebrity, that for that particular celebrity or for that particular account user ID, we will not create the pre-computed feeds. That
Okay.
is what I'm thinking about. So I'm thinking about utilizing the kind of hybrid approach, that okay, like if so in the follow table, right? We will have a flag. So is pre-computed feed needs to be generated for that or not? So for a user that is having a large number of followers, so we will not generate the pre-computed feeds for those followers.
Okay.
For if a user posts that, that is what I am thinking about for mixing, like like hybriding with this and this. So this is what I'm thinking.
So at runtime, you will figure out if a user is following some kind of celebrity user. For those followers, for those users, it will fetch in at runtime. And for other
Mhm.
normal users, it will use the pre-computed feed.
Yes, yes, yes. That is what I'm also like. That is what I'm thinking about. That can be done.
Okay.
Yeah. So I think these solutions should pretty much handle our another problem, that is fan out on write problem. That we were facing. So any questions, Mandeep, that would you would like to add up here?
Yeah, I mean, pretty much clear on this, the architecture part of things, like both write and read. So we
Mhm.
are good there.
Mhm.
We can probably have some discussion, more discussion around the database part of things, like
Yeah.
how you are
So
scaling that and if that can possess any kind of challenges.
yeah. So what I think is that on the scaling part, I would like to use database, some kind of a NoSQL KV database like DynamoDB, because they are actually highly scalable. And as I already told you that how I'm making a database schema as well. what will be the partition keys and the sort keys.
Mhm.
So we already know that they support, like with the help of a consistent hashing and all, we can actually scale and descale those databases at the time of peak and all, right? So that is something that I think should be handled in our database schema design already. But if there is something specific to that, I would surely like to answer that. Like there can be the cases for the uneven reads for sure. Like some posts, let's say, go viral, some doesn't, right?
Hmm.
So so that hotkey problem can actually came into the picture
Yeah, that's what
in
I
our
was
design.
thinking also, like throttling kind of scenarios, even if you are using these
Yeah.
managed kind of databases, which
Yes. Yes.
suggest that they offer a high scale and all, they definitely do.
Yes.
But
Yes.
can those scenarios happen? Like I was coming from that area only, that if
Yes,
those
yes.
both
I
things
think
can appear.
hotkey scenarios can surely happen. Let's say if we have a post and that post is getting like 1,000 requests per second, and we have another post that is getting like like 0 requests per second. So that is not a even load. And if we have like like we have the partition key with the story ID or the post ID I'm talking about, right? So what will happen is that one of our partition will potentially become a hot partition,
Okay.
because let's say that a particular story ID A is getting a lot of requests or read requests. So what will happen is that all our requests will go to that story ID partition, right?
Hmm.
And that partition in our case can become a hot partition, and we can have a hot partition problem that can come into the picture. No matter DDB scales well, but again, like hot partition, hotkey partition problem happens in case of like in case of I will not say viral story. Yeah, viral stories. I can say. I don't know what word should I use for the stories,
Yeah,
but maybe like for the viral stories or something, right? So that is something that can happen here. That is what I feel. So in that case, I feel is that what we can do is we can kind of use a distributed cache. So that can lie between you know the post table, and that basically in the read path and the post table.
by the way,
Right.
like
So
before, where we are storing this pre-computed feed, is it some cache or is it also stored in the
this
dynamo?
is also a table that I feel should be there.
It's in the
Uh,
DynamoDB only, is it?
yeah, yeah, yeah,
Okay.
yeah. So I'm storing it like this. So we will have a user ID for basically user following that particular user, and we will be basically appending the story IDs for that. So that will be the pre-computed feed for that. So as soon as the users post, we will fetch all the followers. For all those followers, we will keep on appending the story ID for those followers. So that is how the pre-computed feed is working. And when we already have a large number of followers for a particular user, we can kind of use a flag that for that, like for that user, we should not generate the
So
pre-computed
for
feed for the
that
followers.
particular user ID, you have list of story IDs. Uh,
Yes, yes, yes. It will be the list of story IDs, right?
and for these story IDs, then you fetch what all content is present in the story ID, is it?
Yes, yes, yes. We will have a story. All stories we will fetch, right?
Okay. So as part of this, like the feed service will first call this pre-computed feed. Okay. So it is basically doing three operations here. First is that it checks for the pre-computed feed for this user. Like it, you
Mm-hmm.
will get the information for normal users. Then you
Right.
get the stories for celebrity users. That's second thing. And once that is done, then you have story IDs. So from that story IDs, you call to this another table and then get this information.
Yes, yes, yes. There will be these calls for sure.
Can we
But
think
I
of any more optimization here, like to make it more faster, like to serve our that 500 millisecond of considering there could be network latency and all as well.
I think we can use some distributed caching here, because stories will rarely will be edited, right? So we can keep a high time to live as well. So that is
Cache
some.
at place of what?
Sorry.
I mean, so the cache on top of this DynamoDB table, or like you are replacing the table with cache? How you are thinking?
No, no, no. I am not replacing it. I will keep it in my read path. So it should lie somewhere between, like feed service as well as this, like story table kind of.
Okay.
So yeah, so that is what I'm thinking about to
Okay.
keep.
So the story service will still persist the data to this pre-computed field, which is a DynamoDB table. But whenever you are retrieving the data, if there are like one or more, okay. Uh,
Hello. Yeah.
yeah. I think it makes sense. Just one question more. Like
Mm-hmm.
once the story is viewed
Right.
by the user, so do you sort out this list like you are maintaining the story IDs, right?
Mm-hmm.
So how do you efficiently handle that? Let's say you have the story ID list in your
Like
pre-computed field.
the story that has already been seen. You're saying that,
Yeah, so
right?
if the story's already been seen, you generally move it to the end of the list, some sort of that thing. And then even if the
Uh,
story is probably most recent, like we are doing that sorting at created at time, right?
mm-hmm.
So even if the story, let's say you viewed a story which is posted at later point of time.
Mm-hmm.
So if let's say we have to add that functionality that a user should be able to view the stories which he has not viewed right now, and whatever
Okay.
is being viewed, they should be moved like at the end of the list basically. So
Hmm.
is there any optimization that you can think of here which we should do?
Right, right. I think for that case, what I can feel is that I can have maybe a separate table with a user ID and a story ID, maybe.
We
So
have that,
what will
right?
happen? So in that case, maybe, or we can, like, let's say if user ID is the partition key there,
Okay.
right? And if we don't take these, so should we take these as a list, or we should have a separate entry like that? I am thinking about
I
that.
mean, whatever
So
works for us. We can
let's
either
say
have a list or the.
if we have a separate entry, and if we can have something called is seen kind of a feature, right? So
Okay.
what will happen is in the particular user ID partition, there will be the stories, there will be the entries in the database, like user ID kind of like this ABC, and created at timestamp will be there, right? And let's say the story ID is like 112 and is seen, let's say, true. And then we have for that particular user only ABC, like the follower only time, let's say story ID 113, and is seen false kind of. So I think I can do somewhat like this also,
Hmm.
uh, but I have to think more on this.
Yeah, that's
uh,
fine. I have just a thought that came to my mind.
hmm, yeah, like it's a good question actually,
Yeah.
uh, because let's say that I think we don't need to maintain a story ID as a list. I think we can maintain the entries because, anyways, the advantage of using a DynamoDB here is that partition ABC will have these story IDs there, right? All the
Yeah, I
story
mean, you
IDs,
can keep a list as well as the entries. Like DynamoDB
right?
supports both. So
Yeah,
whatever
yeah,
is more feasible to use, as in like which requires less computation. So we
right,
can
right.
use that approach.
Hmm.
Both can be implemented in case of DynamoDB.
Right. And I think both will not have a lot of overhead as well because the storage will be on the basis of a partition key, right? So that is what I feel. Yeah.
Yeah, sure. Yeah, we
Yes.
can leave the discussion here for
Mhm.
this particular topic.
Mhm.
Rest, I mean, yeah. Anything you want to like? What were our? Let's go over the functional requirement quickly. Like, did we
Yeah.
address all of them, or do we have something missing?
Yeah.
Or like whatever NFR we suggested. Let's quickly go
Yes.
through them and then yeah, match to our architecture that everyone is what we are supposed to.
Yes. So I think user should be able to create the stories. We are able to do that,
Yeah.
right? And in that stories, we can support text only stories as well. We can have the metadata like stickers, gifs, and emojis, right? Adding the music also, I think we
Yeah,
can
it's
not
we
have.
can
But
treat it as a kind of media that any media
yeah,
is there.
media should be. I
Yeah.
think that our architecture already handles that,
Hmm.
right? with the tagging and mentions feature, uh, so should we think on that more?
No, we can like leave it given we are.
Yeah, and ephemerality also, I think, so the story should be automatically deleted after 24 hours, right? So we can surely have a delete path for that. But again, as you suggest over this.
Yeah, this, I mean, yeah, this deletion part we can quickly discuss if we want, as in like how will you do it in your stories
Hmm. Hmm.
if we want, and notification we can skip. So let's, because it's an important feature for stories, this time frame. So let's quickly discuss on this and then we will end our discussion.
Right. So I think for the this deletion part, right?
Yeah.
Uh, I also need to think about that kind of that how it actually should be done. Maybe should we keep that, like, let's say a timestamp is there, and we try to keep that, like the stories that have been expired in some expiry queue asynchronously, and the workers fetch that, and they keep on, kind of deleting the stories in the backend. So I would like to do it mostly on the backend side, not in the real time, but like asynchronous kind of a way. So that is what I'm thinking about here. If we want to, so there can be, like hard delete, soft delete as well that can come into the picture. But I think we should
Yeah,
have
I
a hard
think
delete into the picture only,
soft
right?
delete can make sense. I mean, to start with, like we can definitely do hard deletes as a like whatever asynchronous mechanism you are suggesting. But
Mm-hmm.
if we say that story should be disappeared after 24 hours, so whenever,
Mm-hmm.
let's say in our feed service, whenever we are generating the feed, if we are
Mm-hmm.
saying that this story has expired its time frame from 24 hours, so we can
Right,
probably skip those stories from the list.
right, right.
And in the backend, we can like either keep those stories forever, like whatever, I
Or we
mean,
can have a kind of a cron job
yeah,
or
cron
something,
job
right?
or like whatever scheduler we kind of run, which delete those stories permanently from your database.
Mm-hmm. Right. So I think, uh, as you said, we will have soft delete for the readers as of now, right? And we will
Yeah, then
have
in
this.
background you can, I mean, run a scheduler sort of thing, which runs probably an hour or daily or so it can delete those efficiently. However you want to do it, probably at a partition level that you
Mhm.
know that these stories belong to a single day, so you can delete them altogether or hourly or.
So I think for each story ID, right,
Hmm.
we can have a explicit parameter expires at first thing,
Yeah, and DynamoDB
right?
supports the TTL thing, so we can
Yeah,
leverage that. But
exactly,
yeah.
exactly. So right. So that's why first I was thinking, why not use a, SQL kind of database? But I think for this use case, I feel when we started designing it, it made more sense to use
Yeah,
GDB and
there are a lot of these features which are inherently built in case
right,
if the database we use, which is, I mean, not managed, we will have to implement it our own. But yeah,
right, right, right.
that is
So
fine.
we will have explicit like TTL as you said also, or we can have this explicit flag of expires at into the picture. Right. So what happens is that when client sends the metadata and that media with that pre-signed URL, so we will have that field set. Right. Also, in the metadata DB with that story ID, what we can use is that we will have, as I said, expires that will be there. And for the media, right? So we can, so let's say for this object storage, right? We
Mhm.
can have some life cycle rule that we can apply that after 24 hours or something, or maybe 48 hours window, right? So here I would like to have a life cycle rule that should apply because S3 supports it out of the box, right? So that after, let's say, 24 hours or 48 hours, we can actually safely auto delete that. So
I
that
mean,
is
you can, but like one problem I see there is like if you are saying that I have deleted it, you should delete
Mm-hmm.
them together from both DynamoDB as well as blob storage.
Right,
So,
right, right.
but if you say that I will use TTL feature in DynamoDB and I will use lifecycle role in S3, then
Mm-hmm.
they like AWS doesn't assure that they will be in sync, right? They
Right,
operate at their own schedule. So
right, right, right.
you will definitely have to ensure that like whenever the entry is being removed from DynamoDB, it should also be removed from the blob storage.
Mm-hmm. Right.
So
So, I think first thing is, as I told you, right, we will have a cache layer also. Like we had a distributed cache here for the story IDs and all, right? So if I let's say we are implementing this feature, so first thing, let's say we are keeping it expires at. I'm not taking into this life cycle rule into account as of now. Okay.
sure.
Another thing here can be that in our cache also, right, for that story. So basically, we are storing the story IDs in our cache, right? So on the read path, what I feel is that we have every story ID has an expires at field. So what we can check is the read path always checks that the server now time is it greater than equal to the expires at, right? And it filters out the expired stories. So that is what I feel that should happen.
Yeah, I mean that's the idea of it. Like if you are removing the things, soft
Right,
delete like we can handle at runtime that whenever we are computing it. And
right,
for hard
right.
deletes, if you are removing
Hard
something,
delete, we
it
can
should
have
be
like this kind of a mechanism only, like asynchronous mechanism that we
it
actually,
should be yeah,
have the workers. Yeah,
whatever
workers that
mechanism
are
we
working.
have, it should be removed from all the places like cache, DynamoDB, blob storage, like
Right,
any data store we have. It should be removed from
right,
everywhere.
right, right, right.
Okay.
So what I feel is that let's say we need to enforce the ephemerality at the every layer, like you said. Right.
Yep.
So metadata needs to have a immutable field of expires that I feel in the story table we will have. Cache have to use the TTLs really well, right? So all that stuff needs to be done, and the read always verify that server time against the expires at. So let's say the server now time should always be like if it is greater than or equal to the expires at,
Hmm.
so we need to filter those posts out, right? And at the back end, I will try to have the asynchronously these workers and all that will do the hard delete. So I think that is what I'm thinking about. But any addition from you will surely help.
I mean, yeah, approach wise, it's good. One idea could be since we are heavily relying on DynamoDB, what you can do is like whenever there is a TTL, right? Whenever you are
Right.
removing the entry from DynamoDB, you have
Mm-hmm.
DynamoDB streams which you can leverage. So at every TTL, you will get that stream that this the event is deleted. So whenever you get
Right.
that event,
Mm-hmm.
your worker basically can consume that event and then remove the entries from both cache and blob storage. So that's another
Right.
idea. But yeah, I think it mostly depends on how you are implementing it. But the idea
Right.
seems good that
Right.
our workers can handle the deletion part and it will delete
Right.
from wherever it is present. So I think
Right.
we are
Right.
good there.
Right.
Yeah, I think we have addressed all the functional requirement per se, and we had like the major part are like story creation and like delivering the stories to users. So we covered that as well.
Right.
So overall, it looks good. Uh, yeah, I mean, uh, good from my end.
Sure. Sure. Yeah. I think if in another like other time when we connect, we can also take it forward, right, to the out of scope requirements, and we can discuss that too because it was really I think a good discussion. Like this DynamoDB streams part that you said, right? So that is something new food for thought that I got here. I will surely explore that too regarding the same. Yeah.
Yep. Yeah, let's end the discussion. Thanks for your time. And if people think of any other architectures, please comment it out. We will meet again till then.